Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 1-10 for course 2, 4th period, mean, median, mode, and range. So our objective is to describe data using mean, median, mode, and range. Okay, many of you are going to be somewhat familiar with this information. Also, you might want to have a calculator handy. It may come in handy later. You can just pause it right now or pause when we get to the time where we need a calculator. Okay, let's get started with our vocabulary. The mean of a data set is the sum of the data divided by the number of data items. So the mean of a set of data is the sum of the data divided by the number of data items. So we would add up our data and divide by however many pieces of data we had there. Okay, our next term is an outlier, O-U-T-L-I-E-R. An outlier is a data item that is much higher or much lower than the other items in a set. And sometimes you can have more than one outlier. You can have a couple that are a lot larger or a lot smaller. You can have one that's a lot larger and one that's a lot smaller, but very much different than the rest of the data items in the set. The median of a set of data is the middle value when the data are arranged in numerical order. Okay, so if you have an odd number of data items, there is going to be an exact middle number. For an even number of data items, we'll see what happens in example 2 down here. So I'm also going to put a little star here and say see example 2, because it tells us what to do in that case, so we don't need to write it over down here. And then when we get down there, you can put a star by it in your notes as well. But basically we line them up and the median is going to be the middle value. If I think of what I know about the word median in another context, the median in a road divides the road in half. Okay, so it goes down the middle of the road, dividing it into two separate sides, so it's the middle. All right, the mode of a set of data, M-O-D-E, is the item that occurs with the greatest frequency, or another way of saying the item that occurs most often. Now, you can have one mode, so you can have one, you can have more than one, or you can have no mode or none. So when it comes to modes, there's a variety of things that you can have. They didn't leave much room. Let me scoot that over. So sometimes you have only one mode, sometimes you might have more than one, and sometimes there are none. If I listed the numbers 1, 2, 3, 4, 5, there is no mode because each number appears an equal number of times. Okay, and finally, the range of a set of data is the difference between the greatest and the least values. So you find the greatest value, and from that we subtract the least value, and that gives you the range. It's basically the difference between the high and the low, if you want to think of it in different terminology. Okay, now let's go through and look at some examples. Remember, at any time this is going too fast for you, simply hit the pause button until you get caught up, because sometimes that may be the case. All right, so our first example is finding the mean. We want to find the mean of the numbers 502, 477, 593, 481, 735, and 614. Okay, so the first thing I want to do is I want to find the sum of those numbers, and then I'm going to divide by 1, 2, 3, 4, 5, 6 because there are 6 items. Okay, remember this is a big division bar. Before I do anything, I have to add up all of these numbers because it acts also like a set of parentheses. So I want to add all of those up. And if you'll get your calculator and double check, you should get 3,402 divided by 6. So I'm going to double check. 3,400 divided by 2 is 567. So the mean of this set of data is 567. Okay, pretty straightforward. Actually, for many kiddos, many people, not just students, mean is also referred to as average. But I'm going to tell you that on most standardized tests now, they're going to say the word mean. So we are going to try to use that term, make a real effort to use that correct terminology in class as well. All right, the next one is finding the median. Find the median of the data in the chart. So here we have a chart of 18 responses. First, write the data in order from least to greatest. So I kind of look through the data and I see the smallest number is 0. So I go in some kind of organized fashion. There are 1, 2, 3, 4, 5 zeros. I usually like to mark it out lightly as I go. For heaven's sakes, don't black it out, because then if you've made a mistake, you can't go back and you're going to erase what's there with your eraser trying to see what it is. Or if you do, shouldn't be doing it with pen. Remember, I do it with pen so you can see it more easily. Then I have 1, 2, 3, 4 ones. So my list of, I now have to list 4 ones. And I wrote 4 there, so because I had ink, I have to blotch it out. All right, and then I should see 1, 2, 3, 4, 5 2s. So 1, 2, 3, 4, 5. Okay. Now I'm down. Next, how many 3s? There are no 3s. No. 1 3, 2 3. So 2 3s. Next number would be 4. Here's a 4. And 8 is the last one. So 8. So I have them in order from least to greatest. Now, this is an even number of items. What that means is I'm actually going to end up with 2 numbers that are in the middle. So the 2 middle values are 1 and 2. And let me show you how you know that. If I take 18 divided by 2, that's 9. So I should count 9 from each end, and it's going to show me the 2 middle values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one, I'm going to put a bracket around it. And go to the other end. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I landed on 2 different numbers, so I know that I have 2 middle values. This is what I was alluding to when I said the median of a set of data with an even number of terms. Find the mean of the 2 middle values. So I'm going to take 1 plus 2, and I'm going to divide by 2 because I'm adding 2 things together. So 1 plus 2 is 3. Divided by 2 is 1.5 or 1.5, however you want to do it. So the median here is 1.5. It is actually, in this case, not a number in our set. So a median could be a value from the data set, or it might not be. All right, so it could be either way. There are 2 quick check questions here. Again, as always, you may pause and do them now, or come back to them later after we finish the notes. On the next page, example number 3 is finding the mode. Find the mode of the data in the chart. Make a table to organize the data. Okay, so they have a table made for us. And here we have the favorite pizza topping of 12 people surveyed. And we have 4 options: peppers, onions, mushrooms, and sausage. if you go through this, you see that we have 1, 2, 3 votes for peppers, 1, 2, 3, 4, 5 for onions, mushrooms 2, and sausage 1, 2 as well. Just a quick double check of myself. 3 plus 5 is 8, plus 2 is 10, plus 2 is 12. So I've accounted for everything. In this case, the mode is onions because there were 5 votes or 5 people that said they liked onions best. In this case, my data isn't actually numbers, it's a list of items. So one of those items is going to be my mode, and in this case, that topping is onions. Okay. Mode may also be numbers if the data set is simply a set of numbers. Excuse me. And our fourth example is elevations in California range from negative 282 feet or 282 feet below sea level at Badwater in Death Valley to 14,495 feet at the top of Mount Whitney. Find the elevation range in California. So remember, range tells us to subtract the largest, greatest value, and take the greatest value and subtract the smallest value. So that's 14,495 minus negative 282. We will add the opposite of negative 282 because that is our rule from adding integers. Okay? So that's why that changed, because remember, to subtract an integer, we can add its opposite. And now I see that I have 2 positive values, so I can simply add them together, and I'm going to get 14,777. So that tells us that the elevation range in California is 14,777 feet. Go ahead and finish the quick check questions before our next meeting in class, and I look forward to seeing you then.